Okay, let's dive right into this. Today, we're exploring a massive underdog story in the tech world. We're talking about liquid neural networks and a $2 billion shift toward edge AI. Right now, the entire AI conversation is all about massive scale, right? Bigger data centers, more chips. But an MIT spinoff named Liquid AI, they are completely challenging that status quo, and what they are building is absolutely fascinating.
Which brings us to a really important question. Does AI actually have to be massive? If you listen to the current industry narrative, the answer screams yes. Tech giants are literally pouring hundreds of billions of dollars into massive cloud infrastructure and trillion-parameter models. The assumption is just bigger is always better, but what if they're looking in the wrong direction entirely? So the crucial point here is understanding the fatal flaw in standard AI. Models like GPT, they basically freeze once their initial training is complete. It's kind of like a student who perfectly memorizes a massive textbook, but then completely fails if you ask him a trick question on the test. If the real world changes, which, let's face it, it always does, the model just cannot adapt to that new real-time data without companies spending millions of dollars and using massive compute power to retrain it from scratch.
Now, keeping those billions of frozen parameters in mind, I want you to think about the number 19. Just 19. It took exactly 19 of these new, highly specialized liquid neurons to successfully steer a real self-driving car. Think about that for a second. 19. It is a staggering difference that literally flips the entire script on how we build artificial intelligence. And that brings us to the core of this explainer, liquid neural networks. Instead of locking up and freezing after training, these continuous time networks actually rewire their own parameters continuously. They adapt to new data in real time, on the fly. MIT researchers actually got the inspiration for this from a tiny, microscopic worm called C. elegans. See, this worm only has 302 neurons at its entire body, yet it produces incredibly complex survival behaviors. Why? Because its neural connections are fluid. They aren't fixed.
And this brilliantly illustrates the difference. When you compare massive standard models like transformers to liquid networks, it's pretty much night and day. Transformers use parallel processing at a massive scale, but again, they're static after training and have an astronomically high compute cost. Liquid networks, while they use sequential processing, they have an incredibly small footprint, they adapt during inference time, meaning right when you're actively using them, and they are highly, highly efficient.
Now, this wasn't just some lab experiment that stayed in academia. This idea spread like wildfire. Liquid AI rapidly evolved from just a 2021 MIT paper into a full-blown company. By 2024, AMD led a $250 million Series A funding round. Now they're rolling out edge models, partnering with Shopify, and even working toward Mercedes-Benz integration by 2026. The smartest operators and investors clearly see the immense $2 billion value in highly efficient AI. So, what does this all mean for you and me? Well, instead of scaling up to even bigger, power-hungry data centers, Liquid AI is actively scaling down directly to your devices. They are building out incredible tech, like the LFM-7B foundation model for local deployment, Hyena Edge specifically evolved for smartphones, and Liquid Nanos. These are tiny, highly energy-efficient models that run directly on iOS and Android. They are essentially replacing those massive data centers with powerful AI agents right in the palm of your hand. Now, what's really interesting about this next part is looking at the actual partnerships, because it proves the real-world demand. Look at Shopify and e-commerce. They need sub-20 millisecond local search to keep shoppers happy. Mercedes-Benz wants embedded in-car intelligence without relying on a cell signal. Brilliant Labs is doing private vision language for smart glasses, and G42 is handling local AI for data sovereignty. The absolute main takeaway here: a pair of smart glasses or a local commerce search engine absolutely doesn't need a trillion-parameter cloud model to function brilliantly. They just need targeted, local efficiency. And honestly, this is exactly where the entire industry is heading anyway. According to a massive Gartner projection, by the year 2027, an estimated 75% of all enterprise data will be processed outside of traditional data centers. That is a huge, game-changing shift. The future of tech relies heavily on fast, adaptive AI running exactly where the data is actually being generated. And that is exactly what we call the edge. So while the rest of the industry is in this frantic race to build giant, incredibly energy-hungry cloud infrastructure, we are witnessing a quiet yet completely revolutionary shift toward on-device AI. So I want to leave you with this thought to ponder.
Is the true future of artificial intelligence locked away in some massive, energy-draining data center thousands of miles away, or is it continuously learning, adapting, and evolving right there in your pocket? Thanks for joining me for this explainer, and remember to always question the status quo.